Hi everyone, this is Brittany Garcia. Today I wanted to show you how you could use Azure Migrate to analyze your VMware on-prem infrastructure and see how much of it is ready to migrate and how your VMs would translate into AVS nodes. I want to give a quick disclaimer that if you have the opportunity, work with your Azure team who can help you with an official AVS sizing or TCO. But I wanted to show a way you could do your own sizing draft to get a general idea. Let's get started. So what we're first going to do is we're going to navigate to Azure Migrate, and then we're going to click Discover, Assess, and Migrate. I have an AVS test migrate project already loaded in here, but I'm going to kind of do this from scratch for you guys. So we're going to create project at the top. We're going to pick a resource group for this to land in. Then we're going to hit create. Now that we have this kind of project created, I'm going to go in here and click discover. So there's two options that you have. You can use an appliance and deploy that into your environment to collect data for Azure Migrate, or you could import a CSV or an RVTools directly into Azure Migrate. I'm going to walk us through how to do that process. At the top, you'll see file type. Because I want to import data from VMware, I'm going to be using RVTools. So I'm going to select VMware Inventory, RVTools, XLSX. I'm then going to navigate to the file. And I'm going to select import. Once our import is complete, we can then continue. But first, I want to touch on this warning. So if you do have warnings, you will have the opportunity to download a file and look at those warnings. So I'm going to download this file. And then let's open it and I'll show you. So taking a look at this spreadsheet that has a list of the warnings from each VM, we can see that it's all the same VM. And what it's just saying is there is some missing memory data or storage data from some of the VMs. So it's saying that it will pick up this data from just a different tab. So instead of using memory and partition tab to pick up specific data, it's going to look at, in this instance, the vInfo tab. And you can see that it kind of explains this is where storage data has been picked up from in lieu of the other two tabs. So that's fine. It's just a warning. It's nothing that's going to stop us from moving forward. So we took a look at that, and now let's get back into the Azure Migrate tool. Okay, once this has finished importing, we will click on the Get a cost assessment of hosting your workloads as IaaS or Azure or on AVS. The assessment type is set to AVS already. If you pop this open, you can see the different options available. The discovery source is imported servers. That's correct. Another thing that I want to do before moving on to the next step is selecting edit for the assessment settings. This is where you're going to get to really define your look at AVS and how AVS will kind of treat your on-prem VMs. So things like picking your assessment type. Is this going to be a new AVS SDDC, or are you expanding one that you already have? In this case, I'm going to select new. Target location, East US is fine, but you have a list of all available AVS regions available. Reserved instance, we have a choice between 1 year and 3 year. 5 year is available in some instances, depending on the node type. You can take a closer look at that in the Azure calculator. It's not yet built into Azure Migrate. I'm comfortable just leaving it at 3 years. Storage type, I'm going to leave all 4 storage type options selected. CPU settings. So CPU oversubscription, let's break that down a little bit. Because this is a virtualized environment, we have this concept of creating multiple VMs that share physical CPU cores. So if we pick 4-to-1, we are assigning more virtual CPUs to VMs than the actual number of physical CPU cores available. Understanding how provisioned your on-prem infrastructure is will help you understand how to pick settings like this. The benefit of oversubscription is it will allow you to run more VMs on the same hardware, which will improve resource utilization. But you need to also be aware that if too many VMs demand high CPU usage at once, you might start to see performance degradation. So our options are as seen on screen. A 4-to-1 is a nice CPU oversubscription. It's not too aggressive. It's not under aggressive. I'm going to leave it at 4-to-1. CPU headroom is referring to extra capacity reserves that you keep available to handle spikes in workload or ensure smooth performance during peak operating times. So we're leaving some CPU resources unused until they're needed, which ensures that there is always some buffer to accommodate a sudden increase in CPU demand without affecting performance. So it looks like you can adjust this all the way up to 25. For my demo, I'm just going to leave it at 0. Higher over subscription can reduce costs by allowing more VMs on the same hardware, but it may impact performance if it's not properly managed. Keeping adequate headroom ensures that performance remains stable even during peak usage. By adjusting oversubscription and headroom, you can tailor the environment to meet the specific needs of your workloads and ensure they run efficiently and reliably. Next, let's look at VM size. So the memory over commit factor, this is referring to the ratio of virtual memory allocated to actual physical memory. A value of 1 represents 100% memory usage, meaning no overcommitment. A value of 2 represents allocating 200% of the available memory. So for 100 gigabytes of RAM, you're allocating 200 gigabytes of virtual memory. The benefit of this is it allows you to run more VMs on the same hardware. However, if too many VMs demand high memory usage simultaneously, it can lead to performance degradation. For the node type, we have 2 nodes available for the region that we chose. I'm going to leave both of those selected. For FTT and RAID level, automatically selected is FTT1 RAID 1 and FTT2 RAID 6. I'm going to just leave these selected. For dedupe and compression factor. So dedupe and compression are techniques used to reduce the amount of storage space required for data. Deduplication removes duplicate copies of repeating data, and compression reduces the size of data by encoding it more efficiently. Adjusting the dedupe and compression factor refers to the anticipated reduction in storage space due to these 2 techniques. As an example, a value of 3 means that for every 300 gigabytes of raw data, only 100 gigabytes of storage would actually be used after dedupe and compression. Adjusting memory overcommit factor and dedupe and compression factor helps balance performance and cost. Higher overcommitment can reduce cost by allowing more VMs on the same hardware, but it may impact performance if not managed properly. So just be mindful of those things. I'm going to leave these 2 as they are. Stretched cluster, this would be if you're using an AVS stretched cluster. For this example, I'm going to select no. For node sizing, we have performance-based and as on premises. So performance-based will consider the CPU, memory, and in-use storage. As on premises sizes the VMs as they are configured on prem without considering in-use utilization data. So it will use total storage. Performance is what I will go with for this example because it's right sizing the VMs according to Azure and only considering the in-use utilization of data. The comfort factor here is a built-in buffer that's added on top of utilization data to account for things like seasonal usage or increase in future usage. By applying a comfort factor, Azure Migrate is ensuring your AVS environment has enough capacity to handle fluctuations in workload demand without compromising performance. I'm going to leave it as 1. The last few things on this section are currency. There's a number of different currencies you can choose from. I'm going to use US dollar. And then this last option is if you are using BYOL licenses from VMware. So you purchased VCF licenses and you would like to bring those over to Azure and use them for AVS. I'm not going to select that in this case. Then we'll hit save. This is what we are trying to do, so I'm going to keep moving forward. Next, we're going to name this assessment. And then we're going to name the group of VMs that we want to select. So this group, I'll just name. I'm going to select all of these machines and then hit next. Then I'm going to create the assessment. Once the assessment is complete, we will be brought to this screen. You can see it discovered 255 VMs. We have the one group that we just created. And to get into the assessment, I'm going to click on this one under total assessments. Then I'm going to select the assessment that we just created. And here you can see there are 252 VMs that are Azure ready. 3 of them have some condition that might need to be looked at before it can be migrated into Azure. And then you can see the nodes that we selected, AV36P, AV64, and it'll tell us based off of the settings that we selected, how many nodes we would need for each. It shows us CPU resources, memory resources, and storage. What you could then do is take this node information and throw it into Azure Calculator to play around with different pricing options, like if you went with a 1-year reserved instance versus a 3 or even a 5-year reserved instance. So you can see that with a little bit more clarity in the Azure Calculator itself. One thing I also want to touch on this page is the limiting factor. The limiting factor will be the factor that determines the number of nodes required to accommodate the resources. So you'll see a limiting factor, little exclamation mark, next to CPU, for example. And that is saying you have more CPU resources than storage or memory. So CPU is what's pushing your node size to grow. There will be a limiting factor in every sizing. This isn't unique to my data, but the limiting factor will change depending on if you're storage heavy or if you're memory heavy or CPU heavy in this instance. There are things you could do if your limiting factor is in storage, where you could use an external storage option for AVS, which would be cheaper than growing in node size which includes the cost for CPU, memory, and storage. So that's a factor you can also consider for AVS. That wraps up my demo, what I wanted to talk about. And just as a wrap up kind of reminder, if you do have the opportunity, work with Microsoft account teams to get an official AVS sizing done. But I just wanted to show briefly how you could just throw your information in there and get a general idea of what your infrastructure on prem could look like in AVS and how those nodes would kind of translate. Hope you enjoyed the video. If you have questions or comments, leave them in the comment section below. Thank you. Have a good day.